Alright, in the 16th century, so about when I was born, mathematicians were developing a formula to solve any cubic equation. Right, cubic meaning the highest power of x is 3. So the expressions were in this form. X cubed minus 12 times some positive constant times x plus some other positive constant. So you'll notice the x squared term is actually missing. Right, so this is a simplified problem. It's not all cubics that ever existed or ever will. It is a good amount of them. And so we're given a graph of a cubic, and we're even given a point that lies on the graph, right? Point A. We don't know what P and R are, but we know that the cubic is of this form. And so the question is to find an expression for P in terms of R. Cool. So, we could start here, right? We have an equation that has an input x and an output y, and the two unknown constants, P and R. If we want an expression for P only in terms of R, we need to get rid of these unknown x's and unknown y's somehow. Thankfully, we're given a point A, which has an x value of 4 and a y value of 40. So we can just substitute that in to our equation and then rearrange for P and R, or for P in terms of R. So let's do that now. So our equation was y equals x cubed minus 12px, and then plus R. Now we know point A was at 440. So what that means is our x value is 4, our y value is 40. So substitute in point A to give us the y, goes in there. 40 equals x is 4. And when you substitute, strongly recommend use brackets, especially when you have things like cubed or multiplying by other numbers. So we have 40 equals 4 cubed minus 12p times 4 plus r. And now we want p on one side of the equation by itself, and then everything else on the other side. So let's just start simplifying this a bit. So 4 cubed is 4 times 4 times 4, which is 16 times 4, which is 64. And now here we have 12 times 4, which gives us minus 48. Of course, we don't know what P is, so that's still there, and we don't know what R is either. And now we want to get P on one side by itself. So I'm going to add 48p to both sides. Right, and since we added 48p on the right side as well, this plus 48p goes to 0, and we're left with 64 plus r. Now we can take away 40 from both sides. And finally, we can divide both sides by 48. To give our expression for P in terms of R. Now part 2. at point B. So remember, point B is is it a maximum? It looks like it's a maximum, right? We don't know. It's about a maximum. Right, so point B, it's true that this expression holds. So this is just restricting the value for P. That's all that's telling us. It's like P must be some value so that the x value of B makes that equation true. And we're asked to show using algebra that in fact at B it must have this x value. So all we're doing here is taking this equation and solving for x in terms of P. So it's rearranging again. So again, we're given an equation and we're asked to show, well, if that equation is true, show that in fact the x value of B equals this number, right? Where P is just some number, so that whole thing is just some number. So we can add 12p to both sides. We can divide both sides by 3. And finally, we can square root both sides. And so the square root of 4 is 2. The square root of p, we could write like that. And remember, when you square root something, we'd have a positive or negative solution. Now, how does this compare to what we're trying to show? So I see a 2. Great. I see a p. What about that 0.5? So our power rules, well, not really a power rule, it's just expressing the root symbol as a fractional power. So for example, the cube root, cube root of x can be written as x to the power of a third. The square root of x can be x to the power of a half. Oh, not a fifth. 1/2, which we know a half is actually just 0.5. So we can apply that here. So plus or minus 2 times p to the power of a half, or 0.5. Now, this is telling us it must be negative. But since we square rooted, we got a positive or a negative. So how can we justify ignoring the positive solution? So let's have a think. So this is the x value at B. So let's go back up to the graph. B is clearly to the left of the y-axis. Therefore, we can just conclude by inspection that the x value for B must be negative. Right? Straightforward. So let's just say that. Ignore positive x value as it is a negative value on the graph. Right, and so we're just justifying why we could ignore the positive solution.